Hi everyone. We'll start today's session shortly. So, till some more participants join in, could you quickly confirm if I'm audible? You can type a yes in the chat box. Good evening, everyone, and welcome to today's webinar, which is the large language models. What they are, how they work, and why they matter. We are thrilled to have you join us as we dive into one of the most, transformative technologies in the world of AI, which is large language models or LLMs. So, in this session, we will unpack the fundamentals of LLMs and also explore how they are trained and discuss the powerful ways they are being used across industries. Also, you'll gain insight into the limitations, future potential of these models, and we'll help you understand not just how they function, but how they matter in shaping this AI landscape. And to help us unpack this fascinating topic in greater detail, we are delighted to have with us our speaker for today, Rushikesh Meherwade, the Vice President of Data Science at Motilal Oswal. He's an accomplished data scientist with over a decade of experience in performance testing, application monitoring, and Java tuning. His expertise spans across NLP, which is the natural language processing, machine learning, and also mentoring tech professionals like us in both startups and global enterprises. So he has also worked closely with top edtech platforms and global organizations such as Capgemini, Renault, bringing both technical depth and educational clarity to everything he teaches. His passion for teaching and hands-on experience in building intelligent systems makes him the perfect person to guide us through this session. Uh, yeah, so how can you all participate? This is going to be an interactive session, so please feel free to drop your questions in the chat box or else in the Q&A tab at any point. So without further ado, let me invite Rishikesh Maharwade to take us through today's session. Yeah, Rishikesh, over to you.
Hey, hi guys. Good evening, everyone. Can you guys hear me? Please chat over message as yes, no, if you can hear me. That would be a great to get started with. Awesome. Just give me a minute. Let me just check. Okay, cool. Yeah, great guys. Great. Welcome to uh, the session where we are going to talk about large language models. So, why, how, when, like these models have changed the whole landscape of AI. Now, because of the large language models, like everyone started talking about AI. Before to that, AI was like a field which was very limited to only some people in like more technological people, data scientists, like very some small part of the group was more focused on the AI. But when the large language model came in, now everybody can use AI. Now there are different level and they are users. Like there are people who build, people who use, people who help others use. So there are just so many industries that have come up with this. So before we start, let me just start with basic of my introduction. Guys, can you see my screen? Can everybody see the screen? Like, are you able to see a slide share? You're able to see the slide share, right? Okay, I see others are saying so. Aditi, like others are saying they are able to see. So I would suggest like if you can quickly rejoin and try again, that should help. Okay, great, awesome. So my name is Rishikesh Meherwadi, and I have like around 13 years of experience in the technical domain. Mostly have been in the software industry, and out of this initial 5 6 years, I used to work in testing domain, which is like more of performance testing. So used to be in a different type of testing related industry. Then we got to see the importance of data. We used to deal with lot of data in the domain, so I started exploring like, okay, how we can improve our work in terms of the data. So that's where I got to see things around data science, big data, machine learning, all these things I started to see. And for many years, I used to just procrastinate, saying that okay, this looks like a very math heavy or something difficult. I used to every year start online courses around that and used to procrastinate. And then um, around 2017, I got into a program with Great Learning, which was business analytics and business intelligence. That was a very early program at that point in this space. So it was more in the R, basic machine learning, and from that point, like it was around 7 years back, but 7 to 8 years back. From that point to this point, the whole domain has changed. Like so many things have changed with respect to this domain, and whole courses have changed, curriculums have changed. So much has changed. I have been leading a team of data scientists. We were building NLP applications, computer vision applications, agentic AI applications, Gen AI based applications. So that's what I have been working on. And on top of it, I like to share knowledge and help share and spread the knowledge with all the people who want to upskill and learn. Okay, so let's get started. Awesome. So first is before we even start, like I want to know what you guys think is large language models. As per you, what is a large language model? And no question is right or wrong. Uh, you guys can try once whatever you think is right. Just answer it. There is no right and wrong. Okay, so just over the chat, you guys can message. What do you think is large language model? Who can tell me? Okay, I'm not getting any responses, so I will move along. Just give me a second. We move ahead. Okay. I'll just quickly share it again if it was not shared. Okay, cool. So LLM is a huge amount of data that can be trained to get some output. Okay, great try, Sonam. That's a good try. So see, LLMs are like these three words that you see: large, language, and model. Models are nothing but some kind of a representation. Model is all about some kind of a pattern representation, some kind of a learning. It's a representation. And large language. So these models are large in size and are a language related representation that they have learned the patterns of the language, how the language works, what is a grammar, how the things are connected to each other, how sentences are connected to each other, how words are connected to each other. So this complicated relationship these models have learned. So these are like advanced systems. They are built on top of machine learning technology, also called as a neural networks, deep neural networks. And specifically within that, there was a very special algorithm or a model that just changed the whole thing. That is transformers. When the transformer came in, it just changed the way people interacted with any type of model. Before to that, there were many limitations in terms of training a model on a larger data. You could not train on larger data. There was a limitation in terms of your GPU, in terms of the data that you can take up with. But transformers changed it. Transformers gave us an opportunity by which we can scale this model to a larger informational load. Okay, so we can just keep on feeding it large amount of data, and this model will keep learning. That was not happening before to that. And these are like trained on billions of parameters. So this neural networks will have a informational understanding that is called as a parameters or neurons. So these are like there are billions of parameters through which they learn. This all learning or language is all represented as a parameters or neurons. And these models can understand and generate natural language ranging from like you guys have, I don't have to say, everybody right now uses ChatGPT, uh, like all this different type of LLM models. Everybody is in some way or the other is trying to interact with this model. So these models can generate one word to full sentences, paragraphs, code, symbols, essays, books, images, you name it, like all type of data that we can ingest. Everything LLMs are able to generate nowadays. So that's the main beauty and power of this type of models. On top of it, now in today's world, like the today's AI driven world, these things are helping us in terms of like creating a core generative AI layer. Now, generative AI is all about generating things, right? Like how do we generate certain content? So, having this kind of large language model allowed us to create this generative AI based layer of technology, which helps us to like generate content, virtual assistants, code generation, image generation, audio generation, nowadays even a video generation. So you can generate a multimodal type of data using these technologies. Then they have a capabilities at scale. Like when they hit a certain threshold, this can like keep on surpassing, and you can generate a long-term data summaries, like you can try to reason on top of this data, like you give it a question and you ask it to think through it. This model can also reason, think, and then give you the answer. So we can scale them to a whatever range possible. And this model they also become very good at doing math, code to a good extent. Okay, like to a good extent, they can work as a human assistant in solving complex problems. Not very complex, but at least a mid-level of complex problem they can solve. Many people say that, okay, are we really supposed to learn programming if large language models are all going to generate everything, right? Like, but it is not the case yet. We still have to be present as a human to guide these machines to uh, accomplish the tasks. It will not be able to do the own thinking for a longer duration. It can do the thinking for a shorter duration and come up with the response. But for complex problems, projects, we still have to be there, guide this model. But other than that, as a initial uh, level, these models can do fantastic work. Okay, and transformers and self-attention. These are the two technologies, as I mentioned, really gave us an edge in terms of this innovation. Like all these innovations related to large language models started because of these two algorithms called as transformer and self-attention. You guys know the full form of GPT? Can somebody tell me the full form of GPT? What is the full form of GPT? Just put it over the masses. Okay, Aditi, great. You have missed one more part of it, but you are, I would say, two by three right out of the three characters. Anybody else? Great, great, Aditi. Yes, perfect. That's right. Yes, yes, Pranjal. That's good. Perfect. So as you see, the name itself has this generative pre-trained transformers. Like these models are generative in nature. As we know, they generate things. They are pre-trained. They are already trained on a large amount of data. They're trained. We don't have to train again. We just directly start using them. So that is like a second part. And then they are a transformer-based model. That's why this name GPT plays a very important role. And then universal language comprehension, these models have understood the intricate complexities in terms of the language. See, language is not an easy thing because we human ourselves can't comprehend all the languages, right? Like we know one language, two language, three language. There will be situations some people can know some more languages, but languages are not easy. Like we as a kid like when we start learning things, we take like good many years to learn the language, like 4 5 years to understand the language in a good sense. So it takes a time. But these models have learned to understand the language at a very different level. They can understand a lot of different languages nowadays. There are good effort that is going on in terms of creating models for Indian languages. Indian government is giving a very good uh, motivation to many big companies to create our own models which are like specialized. But still, these models can understand our languages. But Indian languages, there are many small, big languages. So even we want to cater to that. So there's a good language understanding these models can cater to. Okay. So if we talk about the LLM, if we want to define like what they are, basically they are a type of AI systems. And these AI systems are specialized in terms of understanding and generating the NLP or natural language at a bigger scale. And these models are like large models. You can't like the ones which are used by ChatGPT and all, they can't even fit in any laptop. Like you can't run it from any laptop. You need proper bigger GPUs and not just one GPU. You will need multiple GPUs to host them, and then we'll be able to run it. There are smaller LLMs that we can run on the local machine to try and use it. But otherwise, the ones which are good in capacity, they are very huge, and hosting them is a difficult thing. So they have a lot of data or parameters inside, and they are trained on the vast amount of data. Majority of the internet they have used to train this data. Okay, and enabling to predict, interpret, and produce human-like text. Right? What we are like more interesting thing, why we call it AI, is because it is able to produce a human-like intelligence in terms of the language. That's what like we call it a AI. And the main reason it is able to understand at a human level. Okay. So guys, like if you have questions, please put it over the chat. That will be great. Like in between, I'll be able to see and answer your question. So just don't stop your questions. You can just put your questions over the chat and I'll be able to answer. So here the question means it look too much time to train how it is possible to learn on every field. So Aditi, like these are like generalist models. They are not very specialized in certain things, but they are generic across all the things, right? But sometimes, like some fields will have some special needs there this model may not be able to work good. And that's where AI engineering, LLM engineering, GenAI engineering, all these fields are there where we can make this model work on things which they are not already trained on. So it could be situations where your company may have certain products, or like it could be some knowledge that is only limited to the company, but was not available to ChatGPT to get trained on. Now, how do you give this kind of data, or how do you work on this kind of data? How do you build applications on top of this kind of data? Is what this whole field is about. But these models are trained on a general purpose majority of the data, but specialized thing we still have to work to get them work on. Okay, so what these models can understand well. Okay, so in terms of understanding, these models are trained on majority of the bigger languages like English, Spanish, Hindi. You can even like go on to some rural languages, but not complete local dialects yet, but at least at the state level languages which are there, all those languages in the India also, it is trained on to a good extent. So the other things are programming languages. All the major programming languages, these models can generate code on mathematical equations. You can ask this model to generate a proper derivation of some problem statements, musical notations, sign languages, and body language. There was a recent, I think, just today or yesterday, there was a recent model that was released by Google called as I think Sine Gamma. There was a model called I think Sine Gamma, but they are specializing in understanding the human poses, like the signs. Like you can talk about signs, and this model will be able to tell you signs. So it will be built on top of the LLMs. So the sign related things, the body language, all these are being used to train this model. They can understand it very well. Chemical and genetical codes, Morse code and cryptography related things. If you guys have tried generating some posts or some replies, you will see that this model can generate emojis, symbols, can understand the traffic signs and all, haptic signal, animation, animal communications, artistic expression like dance and visual art. So these are like different things which these models can understand very well, um, and at a raw level, even without doing any kind of a training. To some level, these models can work on these things. Now, there are many different companies who have started with building different type of models for the LLMs. Like they have started with like, but all of them are in competition with each other. If OpenAI today comes up with one type of model, everyone will start working on creating something at a similar level. So all of these companies are in a close competition. But the ones which are at the top right now are like one is OpenAI, second is the Gemini. Anybody knows which are the other models on top of what we have mentioned here? So on top of like BERT, ChatGPT, Llama, Farm 2. What are the other models that you guys have used? I also mentioned Gemini, ChatGPT. Anything else? Okay, Copilot. So Copilot, I would say, would be built on top of the OpenAI ChatGPT right now. So Copilot is basically built on top of the existing models, but it in itself it is not a model. Okay, just to clarify. But yeah, otherwise it's an application that is built on top of this LLM model, but not Copilot is not a LLM. DeepSeek AI, yes, that's a LLM model. Good. Meta is not a LLM model. Meta has released this Llama model. Like if you use WhatsApp in WhatsApp, when you see the Meta AI, that's internally a Llama model. This is a type of a model which is there. Anthropic, yes, Anthropic has multiple models. The major model they have is a Claude. So Claude has multiple variants, and Claude is also a top model like OpenAI GPT models, Gemini, and Claude. These are right now at the top competition, I would say. All others are along the way, but these three are doing the major rounds. Cursor, Cursor would be a application built on top of the LLMs. Okay, like Cursor internally uses different type of LLM models to solve the code related problems. But Cursor in itself is not a LLM model. Great. Perplexity is also not a LLM model. Perplexity uses all the combination of LLM models to come up with a great different type of applications. Okay, different type of applications they will be building for search related use cases. So their core focus is search. How do we make the search better and reduce? So there is a concept of hallucinations where these models can go wrong. Perplexity works more on solving this hallucination problem by looking at only the real information that is present. Okay, so Anthropic, as I said, Claude is their model. Cursor is the, as I said already, Cohere is yes an LLM model. Cohere provides the LLM model. Perplexity I mentioned, great. Bing Chat is also a OpenAI model. Okay, it's again using internally LLM that is like a Chat GPT and all, but Bing Chat is an application on top of LLM, but not the LLM. Okay, I hope that helps you understand some way to like just judge what is the model. I'm an SEO expert. How can I prepare myself for AI prompting or learn generative AI? So probably that's a good question. But let's park it to the end. You can again remind about this question at the end of the session, and we'll try to answer this question and we will discuss on it. Okay, but give me some time and we will at the end. Please remind me again on this question. Great. So let's go ahead. Awesome, guys. Thanks for your response. Great. Now, how does this LLM model really work? So internally, the main thing is they are trained on a humongous amount of data. It's like terabytes of data, and this model set takes almost weeks and months to get trained. It's a huge amount of computation cost that goes into training these models. And they are trained in a multiple levels. So first is called as a self-supervised learning. There is a reinforcement learning, human feedback. So these are like two major components, but now there are also more in terms of reasonings and all. There are multiple steps, but major two parts is self-supervised learning, and then there is a reinforcement learning, human feedback. But all of this is done through the neural networks and machine learning. Okay, neural networks acts as a brain of the whole model, and it's actually learning from the humongous data which is available. So the goal of machine learning and neural networks is to learn from the data. It learns the patterns that is present in the data. These patterns could be simple patterns that, okay, um, for example, it could be how the loans can be given, like when to give the loans to what kind of people, like what is their age, what is their salary, CIBIL score, evaluating all this to decide whether to give the loan or not. And how it is done is using a historic data. Historic data, there will be a lot of information that okay, this type of people paid the loan very well. This type of people didn't pay the loan. So we try to create a model which will learn the patterns as part of this model and then help us use that in the future. In the same way, these models are pattern learners from the data. So in this case, what happens is the massive data set which we're talking about is nothing but a textual information. So when we are passing this textual information to this model, it tries to learn the representation between the individual words, how these words are related to each other. How is this king and a queen word related to each other? How a laptop and mobile as a words are related to each other. So this kind of granular learning in terms of words, context, paragraphs, sentences is all what this model will be going through in the learning phase. Okay, so they identify the patterns, grammar, type of the tone, domain specific angle. So all this type of combination they try to understand. And machine learning plays an important role where it enables the model to do the prediction based on the given information and tries to identify the next word. Just to add, these LLM models are nothing but next word predictor models. Okay. In ChatGPT, when you run a prompt, you will see that It will give you one by one words. Why that happens is because internally this model is trying to make a prediction for every single word. So it just identifies, given a set of words, what is the probability of a next word? Okay, again it'll try to add that, again identify which is the word which is, would be a next most probable word. So it just tries to identify probability to get the next word. That's how this ML model is trying to make a prediction. And this continuous prediction, refinement, loop builds like a coherent and context-aware output for from the LLM models. Okay. So to talk about transformers, as I mentioned at the start, transformers are the core architectural setup which really change the whole thing around this LLM models. Okay, so LLM basically use this transformers internally. There will be multiple stacks of transformer models added, and these models are very good at understanding a long contextual relationships between the words. Okay, it allows the model to weigh the importance of each word in a sentence, similar to how we humans try to define it. See, for example, right now I'm talking about something, okay, but you all know what we are talking about. Like, I'm not mentioning anywhere that okay, we are talking about LLM. I'm just discussing things, but this is all about LLM. So identifying that okay, the discussion that I'm doing right now is about LLM. So this kind of weightage, that okay, what is happening and which words have a weightage in terms of making a decision, is what Transformers tries to do. So it tries to learn the long-term relationship between the information so that the future prediction that it is making becomes a easier part. Okay. So also one more benefit is they also allow a parallel processing. Parallel processing plays a very important role. As these models are very huge in size, if we try to run the whole thing at a one go, it will take a lot of time. But what really happens internally is these models are parallelizable. We can feed the input in one go, and this model will work on a parallel time to give us output. And that saves us a lot of time in terms of training and also in terms of getting a prediction. So inference is a word. We also call it as a prediction. We call inference also. These are like interchangeable words. And then the whole process looks like there is a input data which will be tokenized into individual words. There is a more complexity to that, but we will call like the whole user input is converted to the tokens, a granular level information. Then this transformer plays an important role of trying to learn these individual words and give some weightage to each word. And this weightage will help the model to make a further prediction. So there will be a prediction after that, after the weightage that happens from the transformer. And finally, we start getting the output. Okay, this is like a one by one word output. And this whole thing will happen for every single word in the underlying predictions. Okay, any questions? Please, guys, like whenever you have a question, just don't think about anything and just put it over the uh, chats. Okay, so let's now understand about how this all things came up. Okay, so this models, right? Like the main core technology behind this is the area, not even the technology, but the research area was natural language processing. Okay, the language has been of interest from a long time. And the language, this all things started with like a natural language processing, and that's what we are going more towards. So initially in 1966, ELISA was a model that was like a first chatbot, which was created by like Joseph Weizenbaum, simulating a physiotherapist in conversation, which was a more of a rule-based communication. It used to give like a more rule-based information that you ask it based on the words which are present, it will be able to provide a rule-based response. Then there was a word to vec. The word to vec gave a different dimension to the human words. See, when we write words in the like anywhere, we as a humans are not just treating them as a individual words, okay? But those words have a lot of meaning. For example, when I say, for example, like if we say chatbot, okay, so chatbot as a word has a lot of ingrained meaning, right? Like when you think of chatbot in your mind, a lot of things could come. For example, when we imagine, like just mention about chatbot, it could be like a WhatsApp kind of thing or some kind of a customer care chatbot. So it immediately clicks in your mind that, okay, chatbot, what it is, right? What is it actually? So there's a lot of information that flows inside your brain just for this word. But when we're feeding it to machine, traditionally, we were not giving any kind of this information. We were only saying that, okay, chatbot. But the way we humans try to understand this, we were not trying to do that to machines. That's where this word to vec or vectorization based methods started to provide that kind of information, where these words will be represented in the numeric format. That's also called as a vectors, where these words will be transformed to numerical information, and this numerical information will have a lot of knowledge embedded within that. We also call it embeddings. But the reason to call them embeddings is because they will have a lot of embedded knowledge inside this this vector representation, which will not just talk about the word, but also talk a lot about other aspects of this word. For example, this vectors that we can compare them with each other in terms of the distance. This is how we like you will see some kind of a distance, and we can say, okay, the man and woman as a words. If you try to plot it, this vectors, if you try to plot it, we will see that these two words will be very close to each other as compared to other words. Okay, as compared to other words. That's how these vectors were able to understand some kind of a human information. Then in the 2017, there was a paper called as a transformer. Sorry, it was attention is all you need. Around 2016, 17, this paper was there, attention is all you need, which introduced the transformer. And then there were a lot of improvements in terms of bigger models like BERT, GPT-1. So all these models came around 2018, which were very initial level model. And then around 2020, ChatGPT 3 came in, a model with like a 175 billion parameter. It's a huge model, achieving unprecedented levels of language understanding and generation capability. It was able to understand the language and also generate on top of it. And then in 2025, ChatGPT GPT 3.5 came, and on top of the GPT 3.5, some more enhancements were done to get the Chat GPT. Okay, there is a GPT 3.5, which is a separate version, as compared to the Chat GPT, which was more refined for doing the chat-based communication. So this was introduced around 2022, and then in 2023, there was a GPT-4. So GPT as a era, everybody knows because GPT played a very important role in terms of growth in all these models. Okay, but like now, recently we have O3 models, Gemini 4, sorry, GPT 4.1, GPT 4.5. Um, so there are just so many variants which even now has come up on top of the GPT. Like 2025, we have again more different variants of it. GPT 4 or 4.1. So there are different ones. So key capabilities of this LLMs is like one is the text generation where we are able to generate the text, and this is a core use case which you have been mostly using if you are interacting with the chatbots like ChatGPT and all these chatbots. You will be able to see the text generation. All other things, like even code generation, you will be able to do translation, summarization, sentiment analysis, dialogue-based systems in terms of chats, bug detection from the code or any other kind of a thing, etc. There are just so many different type of use cases which are there. These are available as part of a chat-based UI, and we can also use APIs provided by these different LLM models to automate these things. That's where the real fun comes, where we are able to automate these things. Like right now, you may be using like every time a chat GPT to answer your questions. But imagine like if that same type of question that you ask again and again can be just converted to a product and can be exposed to everyone, and everyone can just use the same thing again and again. So That's where the whole automation related thing that we get from LLM creates a wide variety of uh, like use cases which we can solve, which were not solvable some 3 4 years back. Okay, guys, any questions? Please put your questions if you guys have it. Anything? Okay, great. So let me go ahead. So in terms of use cases, okay, now there are different type of use cases. Now, one thing I would say is every industry is being impacted by the Gen AI, LLM, agentic AI. These are all like different applications which are there. So every industry is being like impacted by the Gen AI. Okay, like be it marketing, sales, coding, um, education, manufacturing, finance, you name it. Every industry has use cases in terms of textual data. Okay, so in terms of textual data, LLMs are doing automation. But now generative AI, this is the LLM, but generative AI on top of the layer on top of it also has other variants, which is like audio generation model, image generation model, video generation model. Even those have a lot of use case. So under the generative AI umbrella, we have language-based thing, vision-based thing, uh, audio-based thing. So all those have a wide variety of applications. Okay, so one is like a product description generator. So you are trying to generate like you have got a product description for a cutting-edge smartwatch designed for fitness enthusiasts. The description highlights like health-related benefits. What does this product do? What kind of things are available? So if you want to sell this over the market, you can ask the LLM to give me a more interactive and engaging definition for this product. So you give it a very brief description, and then on top of it, you ask this LLM to generate a more detailed generation out of it. Like this kind of thing we have used in industrial use case where we had a lot of product reports, like those were 10, 20 page reports. And we use GenAI to just summarize that whole reports into 10, 20 pointers, and those pointers were then sent it over to the clients so that the client don't have to open the whole report. They can just go through the summaries, and if required, they can open the document and read it. But we were able to use the GenAI just to crunch the information into smaller summaries and allow a lesser time, like time saving for our clients. Second could be code snippet creation and bug detection. So code has become a big talking point with respect to the LLMs. You may have heard about all these big companies talking about how LLMs are able to save them in terms of the human efforts. Many people, many companies are also doing the layoffs because there is some form of code automation happening, but it doesn't mean they just want to lay off. They want to start bringing more people who know these technologies and can upskill faster and build things faster. So one is like there will be a job reduction that can happen with people who are not able to upskill. Other is there will be more hiring that can happen with the people who are doing upskill, because now with this companies can build things which they just were thinking, kept on thinking, they can start building with it. Okay. The code plays a very important role, bug detection, code work. There's a good amount of effort goes into it. So these tools can do a lot of support in that. Language translation in the global landscape, language is a very important thing. So language translation is a one of our main use case. And then there is a paraphrasing, rewriting the whole thing. Like you have a, as I mentioned already, like it's the last thing. And from those last thing, we want to get a shorter, summarized version of things. This can be done through large language models. Now, we all talked about good things about LLM. That okay, LLMs can do this, can do that, can do that. So all those were happy pointers. But everything that has a good happy thing will also have some kind of a challenges and limitations also. So LLMs also comes up with their own set of limitations. Okay, these models look smart, but in their smartness, they can sometimes do over smartness. So that we also call as a hallucination. Okay, so they can sometimes there are out of the blue, this models can bring out something which is not there in the reality. So we have to be very careful with respect to the hallucination. So that's what in the GenAI engineering, that's what we try to do. Like when we build products, we try to say that, okay, if the model is going to do hallucinations, how do we control it? How do we handle it so that it will not impact the real customer? Because your customer should not be fed with incomplete or inaccurate results. Okay, but LLMs can do that. Bias and ethical concerns. So these models are internally biased. And these models are trained on the data that is available over the internet. So if you think of it, whatever is available over the internet is also biased. There could be some political biases, gender-based biases, regional biases, country-specific biases. So there could be different type of bias that is present over the online content, which is used to fine-tune these models. So whatever is available in the data, that's how these models are going to be. So there will be bias in this. So if so, these things we have to understand when we are building products for GenAI-based applications. So they can inadvertently reflect and amplify the biases present in the training data. This can result in discriminatory, offensive, and some unethical outputs. And there is a good concern that is going on in terms of like sensitive areas of hiring, healthcare, legal advisory. These are where uh, a very important uh, things are required to control this. You can't have like in legal advisory, hallucinated information can't be provided. In healthcare, you can't have some kind of a hallucinated or unethical behavior um, in that, like be it unethical or be it like biased hallucination. You can't have this kind of things. So that's what needs to be managed. Then there is a domain mismatch. These are already trained on a large amount of data. But when it comes to certain niche or small specialized subjects, these models may not be good with that. As I said in the start, these models are generalized in nature. Okay, they can answer things around the general construct. But if there are things which requires a special attention, which are specialized but not available in a big terms, then this model needs a fine tuning. They may not be able to answer those things out of the blue. So this results in generic or inaccurate outputs in domains lacking detailed training data. Technical limitations like word prediction issues, there are words which may not be present in the model learning itself. So difficulty with rare words or complex phrases can lower the quality of output. So it based on the quality which is used to train it, the overall technical limitation will also come, especially in translation, technical writing. If you want to use some specialized words, it all depends on how it was trained on. Real-time translation challenges. So this model, as I said, goes by one word. You get one word, again next word. But it takes a time, right? So there are different variants, like there are some models which are built for faster output but may not be very accurate. There are some models which are built for better output but could be slower in time and latency. Okay. High computing demand, particularly for underrepresented languages, affects the performance and quality. So, as I said, if we think of the languages which are very regional and like very local to certain areas, those kind of languages may not be understood by the models. Okay, and then scalability and environmental impact. So, training large models consume a huge amount of energy. So GPUs are used, but GPUs are used means they will be consuming the energy. And as I said, these models are going to consume a large amount of infrastructure. And large amount of infrastructure, with that, there will be some harm that will also happen to the environment. Okay, so all those things are like connected um, through this. Okay, raises concerns around the sustainability of scaling LLM further. So if you think of it like training GPT-3 used 1,287 megawatt, enough to power a 4 lakh 25,000 homes for an hour in the US. Right? You can imagine the amount of resource consumption which is happening with this model. If you talk about future, there is a rapid development that is happening. Like even people who are good in this field are not able to capture the speed with which the things are moving, right? So there are just so many new things which are coming. Every day there are new learnings. So all of this will get us a new use cases, smarter applications that we can build through it. The conversation will increasingly shift towards more of how do we build more ethical, responsible, and human value applications, right? Like if certain thing is good, there are also bad implications of it, right? Like if you're allowed to keep a gun, but there are also bad impacts to keep a gun. So similarly, LLMs also like if we can use LLM in a good way, there are also ways in which this can be used in a bad way. But we have to understand what is ethical and what is unethical. Expect a workforce reshaping with GenAI paving the way for flexible work models. That's possible. Like as things start speeding up, people are able to achieve more in lesser time, then it's possible that overall life of people can improve over the future. GenAI in productivity is like every industry is getting transformed. Everyone needs to learn the GenAI, and then it is bringing a lot of productivity gains, especially in the tech, software, but not just these two. I would say sales, marketing, finance, every industry, there are great potential gains in terms of productivity. And in some cases, development productivity has already increased by many of the companies. You may have heard of Apple, Microsoft, Google, Microsoft talking about getting a 30% reduction in time with respect to building codes. Okay, so democratization of AI plays a very important role. And then, as I mentioned, ethical and workforce shifts plays a very important role. Democratization will be like it will be embedded in everybody's life over the time. Uh, just over the next 5 years, how the things are going to move. There is not people who are already in the field can't imagine like how all of these things are going to turn out. It's just very dynamic right now. And ethical things are playing very important role. Like the role of ethics in AI development and use will be central and going forward. Okay, so if we just talk about some expert perspective, it will be here when conversations gravitate to more of Gen AI, ethics, and what it means to be human. Because now, if Gen AI is taking some part of our role of human, now what does the human will look like or what he will do? And the human definition has been changing from generation to generation. People who were doing the farming or people who were just living in the caves, and now the way we are, the definition of humans have changed. The way they looked at themselves and the way they looked at the world has changed a lot over the years. The same way, these things will keep changing. Okay, summary. This LLMs are being used across the industries, customer service, content, software. Different fields are getting impacted. They support automation and innovation by generating more human-like language. LLMs can provide biased or inaccurate responses that can have a significant impact in terms of the customer service and also may require a lot of computing power. It's very important for organization to use these models very responsibly and thoughtfully because there are right things and there are wrong things. We have to identify the boundary and then think that okay, where we are going to work at a ethical level. As LLMs continue to evolve, professionals need to stay aware of their potentials, risk, and what kind of long-term impact these things are going to have over the world and over the life of humans. Okay, so that's what this whole LLM would be. So now to talk about the Great Learning. Great Learning has been a leading edtech company in professional and higher education space, and they have a best completion rates, learner satisfaction, and career transition related statistics. So there is a program for artificial intelligence and machine learning, a PGP program, which is highly regarded in the different areas. They have a 12-month program, which has a very flexible structure, and it is provided by like Great Lakes plus the UT Austin combined together. Ranked number one for 5 consecutive years, commercial experience, hands-on learning, and also have a peer-to-peer learning. So you will be learning by some expert faculties who are already having a great experience in the industry with education and industry both. Okay, so there's a curriculum where you'll be learning foundations and also self-paced module. So foundational concepts will be there, for example, Python, SQL, statistics, and then there'll be self-paced modules to learn the more advanced things like recommendation system, object detection, segmentation, and also advanced Gen AI. Integration with lot of tools, immersive experience. Okay, and that's about the whole program. Yeah, but I'll be open to any questions if you guys have to answer. Uh, Please go on. But I hope this session was useful to you. You were able to learn something and understand the importance of this technology, which is changing every industry right now. And like everybody should start learning and upgrading themselves in terms of these technologies because they are going to have a real impact on the overall industry. That's for sure. Okay, how much coding language I have to learn? As I have very less coding knowledge, I want to learn generative AI from basics to advanced. Answering the last of session. Okay, sure, Robin. So, see, Robin, what really happens is coding language learning becomes a very important part. Okay, understanding the foundations of the language is very important. It doesn't mean that you have to get very mastery over it, but learning the fundamental plays a very important role. Nowadays, using a mix of the code generation tools and your basic knowledge, you will be able to build workable products. Okay, like having a mix of, we also call it a vibe coding right now, but vibe coding is pure uh, like without code, but that works only in some cases, but for majority of the cases you need to work with the knowledge of the code. You need to understand how this programming languages works at a fundamental level, so then only like you will be able to build things without a lot of trouble. So I would say learn these things at a fundamental level in a good way. And people who want to know more, please fill in the form that is shared by the Great Learning team, and they'll get back to you with more details. Okay, so Robin, like uh, going for SEO, say all about this prompting, making use of your domain knowledge in the SEO, and then trying to apply that using the generative AI. You have to understand how fast you will be able to generate SEO content by using a better prompting. But once you have a domain knowledge of SEO, these things become more better for you. You will be able to generate some very good content um, using the Gen AI. And that field is right now having a lot of impact. So there's a GEO right now, AEO. There are many things which are people are talking about. So lot of impact is coming to this field right now. Okay, great everyone. I think it was a great session. Thanks for all the questions, and it was a great session to be with you all. So take care. Best of luck to you all.
Hey everyone, please take a moment to fill the feedback form shared. Copy the link and then you can drop out. Cool, and thank you, everyone. Bye. Have a happy evening.